Good morning. Today we will start with a new module, and it is rotational mechanics. Here we will learn about rigid body and rigid body dynamics. Okay, so let us begin with the class. Uh, you might have heard about what a rigid body is, right? So let us see what is a definition for rigid body. A rigid body is a system of point masses where the distance between all pair of masses remain constant. A rigid body thus maintain its size and shape during the motion. The fixed axis will not move during the motion of the body. Okay, so briefly, a rigid body, it is nothing but a solid body, and it can have any shape. It can be like this, and what they are saying is that it is composed of a lot of point masses. That is like this. It is composed of a lot of point masses, and the distance between any pair of point masses remains constant. That is the distance between these two, or 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 like this one, or the distance between these two, like that. So each of the distances between any pair of point masses will remain constant. So that is the concept of a rigid body. It is not having any particular shape or size and like that. It is composed of a lot of point masses, and the distance between any pair of point masses is supposed to be a constant. Okay. So when you are asked to write the definition for a rigid body, you have to mention what is this one. Okay. The region which is underlined. That is a definition for a rigid body. Now let us see what happens when a rigid body rotates about the axis. See the figure here. Z dash is the axis of rotation. Okay, so when this is the rigid body. Now when this rigid body rotates about the axis of rotation in the figure, say Z dash, then what happens is that each of these point masses that the rigid body contains will move in a circle whose center lies on the axis of rotation. Okay, we have already said that a rigid body is made up of a lot of point masses, right? So when such a rigid body rotates about an axis, each of these point masses will also move in a circle whose center lies on the axis of rotation. At the same time, each of these point masses will move through the same angle during a time interval. Here that is the angle omega. Okay, so that is the concept. Here in order to consider the rotation, we have taken a reference line, that is OR, and Z dash is the axis of rotation. So you need to study only this one. That is, first study the definition for a rigid body, then just mention what happens when a rigid body rotates about an axis. What happens? Each of the point masses that the rigid body contains will also move in a circle whose center lies on the axis of rotation. At the same time, each of these point masses will move through the same angle during a time interval. Okay, so this much you can write when you are asked to write about a rigid body. First the definition and the concept, that is what happens when a rigid body rotates about an axis. Okay, now as usual, in order to describe the motion of a rigid body, we need coordinate system. Now let us see another definition, that is angular displacement. Okay, so for that, let the angular position of a reference line changes from theta 1 at time t1 to theta 2 at the time t2. Okay, that is, suppose that angular position changes from theta 1 at time t1 to theta 2 at the time t2. Okay, then angular displacement in the time interval t2 minus t1 will be theta 2 minus theta 1. This will be the angular displacement. Okay, that is if angular position changes from theta 1 at time t1 to theta 2 at time t2, then the angular displacement is given by theta 2 minus theta 1. Okay. Uh, Here the angular displacement is a vector. Its direction is given by right hand screw rule and it is along the line perpendicular to the plane of rotation. Okay. Right hand screw rule and thumb rule and all you might have learned in your 12th standard. So when you are asked to write about angular displacement, you have to write up to this. Okay, first one, angular displacement. Next, let us learn about angular velocity. Angular velocity is denoted by the letter omega and it is defined as rate of change of angular displacement with the time. Just now we have discussed about angular displacement, right? Now the rate of change of angular displacement with the time, that is d theta by dt, will be your angular velocity omega. Okay, see. And here can apply limit also. Limit delta t tending to 0. Delta theta by delta t will give you d theta by dt. Angular velocity is also a vector whose direction is perpendicular to the plane of rotation and is measured in radians per second. So when you are asked to write about angular velocity, you have to write from here to this. Okay, so you got two definitions. Now, what is meant by angular acceleration? Now we have learned about angular velocity, right? So if omega 1 and omega 2 are the angular velocity of the body at time t1 and t2, then angular acceleration will be rate of change of angular velocity with time, and that will be angular acceleration alpha. See. Okay. Now angular acceleration is also a vector whose direction is perpendicular to the plane of rotation and is expressed in radians per second squared. So when you are asked to write about angular acceleration, you have to write from here to here, third definition. Okay, so from up to this you have learned four definitions. First one, what is meant by rigid body and what happens when a rigid body rotates about an axis. Now next one, what is angular displacement? Right from here to here. What is angular velocity? Right from here to here. What is meant by angular acceleration? Right from here to here. Okay. Now, next is an essay question, that is derive the equation of motion of a rotating rigid body. Okay. So when you are asked to write an essay on that, first you give the definition for a rigid body. Okay, what is meant by rigid body? The definition that I have just said, and also just mention about what happens when a rigid body rotates about an axis, and after that you draw this figure. Then write the sentence, consider a rigid body and let its mass be capital M. Let it rotate with an angular velocity omega about axis of rotation is a z dash. Okay. Then this sentence is similar to what we have already discussed. That is, when the rigid body rotates about an axis, each of the point masses in it will also move in a circle whose center lies on the axis of rotation. At the same time, each of these point masses will move through the same angle during the time interval. Okay, that you have to write. Then start the derivation. Now you just consider a point mass at the point P. See, here you just consider a point mass located at the point P. Let its position vector be vector R. Okay. Then let the angular velocity be omega. Then the velocity will be equal to V equal to omega cross R. That is, you have to consider a point mass at a point P. Let the position vector be R and let the angular velocity be omega. Then the velocity will be tangential to omega and R. That is, it will be equal to V equal to omega cross R. Now, here, as I already said, m is the mass of the rigid body and small m is the mass of the point mass. Okay, so not that difference. Now Let P be the linear momentum of the point mass. Then angular momentum will be R cross P. R cross P is the expression for angular momentum. Okay. So if P is the linear momentum of the point mass, then angular momentum will be R cross P. That is again equal to R cross mv. Why? Because P is momentum. Momentum is nothing but mass into velocity. Okay. That is the angular momentum of the point mass. That's why we are writing it using small p. Now, what will be the angular momentum of the whole rigid body? We have already discussed that a rigid body is composed of a lot of point masses, right? So, if p is the linear momentum of the point mass, then this will be the angular momentum of the point mass. So if you want to get the angular momentum of the whole rigid body, then you have to take the summation of this one. Okay, see, sigma r cross mv, that will give you angular momentum of the whole rigid body, that is denoted by capital letter L. Then sigma is kept as such, r is kept as such, m is kept as such. Instead of v, they have written omega cross r. Why? Because here this is the expression. Okay. Then sigma, you just write this together. That is sigma r cross m omega cross r can also be written as sigma mr into omega cross r. Okay. Now taking the vector triple product, that is up to sigma m, it is kept as such, r cross omega cross r, this one can be written in this form, that is by applying the vector triple product law, that is m r dot that is r cross omega cross r, this can be written as r dot r omega minus r dot omega r, that is the triple product of r cross omega cross r, this one. Okay. Now again sigma m is kept as such, r dot r square, omega is kept as such, then r dot omega cross r, this r dot omega is written as r omega cos theta, vector r is kept as such because r cross omega is r omega sin theta, r dot omega is r omega cos theta. Okay. Now theta is the angle between vectors r and omega. Okay. Then next, so that will be the expression for the angular momentum of the whole rigid body, that is denoted by capital letter L. Now if you want to find the component of that L along the axis of rotation, what you have to do, this formula is one is written as such. The only thing is that this vector r, they have replaced it with r cos theta. Why? Because we are considering the magnitude of capital letter L, that is angular momentum along the axis of rotation. So it will be r cos theta. If it is perpendicular to axis of rotation, then we will be taking r sin theta. Right? Okay. Now again this one, see, omega is taken out, sigma mr square is kept as such, and on expanding the bracket we will simplify it as 1 minus cos square theta. Again see the fifth equation, omega sigma mr square, 1 minus cos square theta sin square theta. Okay. Here as already you know, r sin theta is the perpendicular component, so it r sin theta will give you the perpendicular distance of the point mass at P from the axis of rotation. So now you are going to rewrite this. Here this component of angular momentum, capital letter L, along axis of rotation is denoted by L0, right? So it is L0. Now you are just asked to replace r sin theta with r0. So how will this equation look like? L0 equal to omega sigma m, r sin theta is r0. So r square sin square theta will be r0 square. See, that is how you got equation 6. Now here the sigma m r0 square is called moment of inertia of the body about axis of rotation. It is a very important quantity in rotational dynamics. What? moment of inertia. Okay, it is given by I is equal to sigma m r0 square, and this is the definition. Moment of inertia of a body about an axis of rotation is nothing but sum of product of masses of its constituent points, that is sigma m, and square of their respective distance from the axis of rotation, that is r square. Okay, that is moment of inertia, you know it is mr square. So in the case of a rigid body, since it is composed of a lot of point masses, we can define the moment of inertia of a rigid body as the product of sum of masses of the point objects into square of the perpendicular distance of the point of masses from the axis of rotation, r square. Okay, so we can write equation 6 as this one, because L0 is equal to omega is kept as such. Sigma m r0 square is moment of inertia. It is denoted by capital letter I. Okay, so your equation 6 can be written as L0 is equal to I omega. Okay, now in general, if rigid body is composed of masses, say small m1, m2, m3 like that, and let the perpendicular distance of each of these point masses, say m1, m2, m3, etc., from the axis of rotation be r1, r2, r3, etc., then moment of inertia of the rigid body about axis of rotation will be sum of all these things. See, I equal to m1 r1 square plus m2 r2 square plus m3 r3 square, etc. Now moment of inertia depends on mass of its constant point masses and their distribution about the axis of rotation, right? This is also an important sentence, because I is equal to mr square, product of mass of the point object or the point mass and square of its perpendicular distance from the axis of rotation. Okay, now this rigid body is composed of a lot of such point masses, so it will be the sum of, if this is the moment of inertia of the first point mass, then the second point mass, third point mass, etc. So moment of inertia of the whole rigid body will be equal to the sum of the moment of inertia of the individual point masses. So moment of inertia depends on mass of the constituent points m and their distribution. Distribution means their perpendicular distance from the axis of rotation. Now the unit of moment of inertia is kilogram meter square. Now we are going to derive the equation of motion of a rotating rigid body. For this, first we have to differentiate equation 4. What was your equation for? L is equal to sigma r cross nv, right? So take the differential on LHS and RHS of equation 4. So it will be dl by dt is equal to d by dt of sigma r cross mv. See this one. Okay, now next one, sigma r, that is here what they have done is just differentiate this, that is first function into derivative of second plus second function into derivative of first. You will get like this. Okay, now sigma r is kept as such, cross d by dt of mv. What is d by dt of mv? mv is momentum, right? So dp by dt, rate of change of momentum with the time. What is it? Force. That's why it is written f here, plus sigma v. Then m here, sigma dr by dt. Okay, what is sigma dr by dt? What is dr by dt? That is rate of change of position with the time, dr by dt. That is nothing but velocity. So dr by dt is v. So sigma v into mv is written as such. Again, this is again equal to this one. You are neglecting this. So you are left with the sigma r cross f. Okay, the second term you are neglecting. So sigma r cross f, it is nothing but torque, toe. Okay, torque acting on the body. Sigma r cos f is torque acting on the body. So this equation 9, that is tau equal to r cross f, uh, that is sigma r cross f is equal to tau. Okay, so what is on your LHS? dl by dt, that is rate of change of angular momentum with the time, that is equal to torque tau, that is this one, dl by dt, rate of change of angular momentum with the time equal to tau. This is the equation, that is equation 9. We will represent the equation of motion of rigid body rotating about a fixed point. Now just write the statement also. Statement is written here, that is the equation states that is dl by dt is equal to tau, states that rate of change of angular momentum of a rigid body about a fixed point is equal to sum of moment of inertia of sum of moment of forces about that point. Okay, that is nothing but tau, that is rate of change of angular momentum of a rigid body about a fixed point is equal to torque acting on the body. Okay, that dl by dt equal to r cross f, which is again equal to tau. Okay, that is the equation of motion of a rigid body rotating about a fixed point. Now, so that is the essay part. Up to that much is your essay. Now just one or two points. That is for L equal to I omega. There is one relation like this. That is angular momentum L equal to product of moment of inertia I and angular velocity omega. Now we have derived one equation of motion of rigid body. What is it? dl by dt equal to torque, right? So just write that. Then d by dt of, this can be again written as d by dt of I omega. Why? L is equal to I omega. Then I take I outside, then d omega by dt. Then d omega by dt we have already discussed. What is it? It is the rate of change of angular velocity with the time. What is it? Angular acceleration alpha. So you wrote, get one more expression, that is I alpha. Tau equal to I alpha. One more relation you obtained. Okay. Just remember that equation. No need of including it in the essay. Okay. So keep in mind that equation. You may be asked to solve problems related to that. Tau equal to I alpha. Relation between torque and angular acceleration. Tau equal to I alpha. Then that is this equation. Tau equal to I alpha is another convenient form of equation of motion of a rigid body. That also can be taken as another form of equation of motion of a rigid body. Then here, if alpha equal to 1, that is tau equal to I alpha. If alpha is equal to 1, what will be tau? Tau will be equal to I. That is tau will be equal to moment of inertia. That is, it will give you another definition of moment of inertia, which states that moment of inertia of a body about an axis of rotation is equal to magnitude of torque that produces unit angular acceleration on the body about an axis. That okay, so that is tau equal to I alpha. When acceleration is 1, that is when alpha is equal to 1, that is for unit acceleration, your tau will be equal to I. That is your moment of inertia, or tau equal to I or I equal to 2. That is your moment of inertia I will be equal to magnitude of torque that produces unit acceleration. Okay. Now, if tau equal to 0, then using equation 9 and 10, we can reach, that is if tau equal to 0, then using equation 9 and 10, we get d I omega by dt equal to 0. That is I omega will be a constant. It is nothing but law of law of conservation of angular momentum, and it states that is what is law of conservation of angular momentum. In the absence of external tau, that is when tau equal to 0, the angular momentum of the body about axis of rotation remains constant. Okay, so here I will tell you once again which are the important points that you have to discuss. Here you have to study the definition for rigid body and what happens when a rigid body rotates about axis of rotation. Then what is meant by angular acceleration? So for that you have to write from here to here. Then what is meant by angular velocity? This one. What is meant by angular acceleration? This one. Then derive the equation of motion of a rigid body. So start from here up to this much you have to write. Okay, up to this much is your essay. Then just remember the equation, tau equal to I alpha. Then just note the definition for another alternate definition for torque, that is another alternate definition for moment of inertia, that is when alpha equal to 1, tau equal to 1, this one. Then state law of conservation of angular momentum, then you have to write from this one. Okay, so derive equation of motion of a rigid body is one of the possible essays from this unit. Okay, thank you.